Assalamualaikum. So for our presentation, we will start with me. So my name is Nur Ifa Farisha binti Khairuddin, and I will explain about the question 1, which is for chapter 3, bipolar junction transistor. BJT is a type of transistor that use both electron and holes as charge carrier. It also have three layers. So there are two types of BJT, PNP and NPN. Okay, for the circuit of emitter bias, phase bias and voltage divider are almost same, but the resistor part is slightly different. Let me compare for emitter bias and phase bias to show what the difference of the resistor. So phase bias and emitter bias is almost same. The circuit is almost same, but phase bias don't have resistor at emitter, but the emitter bias have resistor at emitter. So the question asks to design the emitter bias. So firstly, we have to draw an equivalent circuit. After draw the equivalent circuit, we have to separate the circuit to VE loop and CE loop. It is more easier to find the value what the question to ask. So VEB equal to 0.7 is for PNP. IC is equal IE. IC is equal to beta IB. So IE is beta plus 1 IB, and IE is equal to IC plus IB. So the question give hint ICQ equal to 1 over 2 saturation, VCEQ equal to 1 over 2 VCC, and VCC is 25 volt. IC saturation is equal to 10 milliampere, and RC is equal to 3 RE. So firstly I use CE loop to find RC and RE. Okay, for find the IC is equal to the ICQ. So it is 5 milliampere. So VCEQ is equal to VCE. So we get 12.5 volt. IE is equal to IC. So use the CE loop to find the RC and RE. So negative VCC plus ICRC plus VCE plus IERE equal to 0. Okay, put the value of VCC and VCE from what we get. So VCC is 25 volt and VCE is 12.5 volt, and ICRC plus IERE. So IC and IE is equal. So I combine to IC only, RC plus RE. So put the value of the IC 5mm, and the question mentioned RC is equal to 3RE. So substitute of RC to 3RE to get the RE. So I get RE to 625 ohm. So to find RC, 3RE, so 3, 625, and we get 1875 ohm. And now we calculate to find the IE equal to beta plus 1 IB. So we want to find the IB. Substitute the value 5 milli equal to beta. Beta given is 130 plus 1 IB, and IB equal to 38.17 microampere. Okay, done. So we get RE and RC, and now find the RB. So to find the RB, we use the VE loop. Okay. RB is equal to VCC minus VBE. VE. IB. So just input the value 50.7, and VE is equal to 3.125. How to get the VE? VE is equal to IE RE. So IE milli, 5 milli, and RE is 625 ohm. So we get 3.125. So over IB is 38.17 microampere, and RB is 554.76 ohm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Kurato Ain Zana binti Wan Syari. For today, I'm gonna be presenting assignment EE2213 Set E. Before we start on the question, I'm gonna be explaining to you guys what is Zener diode. What is Zener diode? Zener diode is a special type of diode designed to allow current flow backwards when a certain set reverse voltage. Zener diode is divided into three categories. First, fixed Vin and RL. Next, Vin variable RL. And lastly, variable Vin fixed RL. It says that the diode will be off stage when Vz is greater than V and greater than 0 V. When it's on stage, V is greater than Vz. Among the Zener diode application, it can be used as voltage regulator, as reference element, surge suppressor, and lastly, in switching application and clipper circuit. Assignment BE2213 Set E question 2. From the question given, we can see that VDC is fixed at 30 volt while RL is various. Theoretically, a fixed VI variable RL. Offset voltage BZ. RL should be various to ensure the zener is in the on stage. Determine RL minimum that will turn on the zener diode by using this formula. Noted, any RL values greater than R minimum will get zener diode in on stage. When diode in on stage, resistor remain fixed at VR equal to Vin minus Vz, IR equal to VR per R, and Iz equal to IR minus IL.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aisyah binti Rosli, and I will explain about the calculation in question 2. Given in the question is VDC or Vin equal to 30 volt, Iz maximum or Izm equal to 15 milliampere, Iz minimum or Izk equals to 1 milliampere, and also voltage zener is given 10 volt and R1 is 1 kilo ohm. And the construction of the circuit with the value is as shown in here. First, we can use the secondly, we use the Iz minimum, which is 1 milliampere. We assuming it is off because the zener diode mentioned to be in ideal model. Then we can proceed to find the another RL value by using the same method. With the final value, we can know the range of RL that will turn on the zener diode, which is from RL minimum is 526.32 ohm until RL maximum, which is 2 kilo ohm. As explanation before, we are noted that to ensure the zener diode is on, the RL must be greater than RL minimum. As in ideal model, we can find the value of RL minimum by using the formula R multiplied with Vz divided by Vin minus Vz, and we get the answer is 500 ohm. So, the RL at 50 milliampere, which is 2 kilo ohm, and the RL at 1 milliampere, which is 526.32 ohm, are greater than RL at 0 ampere, which is 500 ohm, and the zener diode is on.